Good evening, everyone. It's Dr. Shiva Ayadure, and I'm glad to be here. It's Friday. Great to have everyone. See a lot of people from all across the world. We have Australia, Ohio, Canada, what else? Florida, Scotland. Great, and people are joining. So welcome. Today we're going to be discussing a topic on colloidal silver and its effects at a molecular systems level. People from San Diego, Maryland, Texas, great to have you on. And this is a topic that really came from you, just like the adrenochrome topic came. People wanted me to take a molecular systems analysis as a guy who does this for a living. You know, I have my PhD, as everyone knows, is in the field of biological engineering. I created a technology, which I'll talk about, CytoSolve, which allows us to do this kind of analysis. Anyway, we have Sydney, Michigan, California, Toronto, Haverhill, Massachusetts. Great. Those are local. It's good actually when we have local people here. Indianapolis, Vancouver Island, Montreal, Canada, Taiwan. That's new. Great to have you. Virginia. Who else do we have? Connecticut, South Dakota. Wonderful. Toronto, New Mexico, Amsterdam. God, I think we're going to have every town and every country eventually represented here. It's great to have people. But anyway, colloidal silver is something that's been put out there as an antimicrobial. People take it as an antiviral, antibacterial. And I think I know people who've attempted to just say, hey, it has this effect or that effect. The sensors go after them. So my intention here is to really do a systems analysis based on the science that's out there and use that scientific understanding to really present to you mechanisms of how this may actually work. So one is what we're going to do today is, first of all, do a quick review on what is CytoSolve, the methodology. Then we're going to really review the immune system relative to virus replication, the processes that occur. Then we're going to give a little bit of background on what is silver and its forms that it comes in: ionic silver, what's called a nanoparticle version of silver, and really colloidal silver, which is really a mixture of what's called a colloid in chemistry. It's a mixture of the ions surrounding these nanoparticles. That's what colloidal silver is. So having given that, we're then going to look at the mechanisms from what the literature and the science and the mechanisms say, how the colloidal silver affects antiviral activities, which is one part of immune function, and then the antibacterial activities. So we're going to cover that and we'll summarize. And then we can take questions via right here. You can write in your questions. And I hope this helps. But anyway, I want to thank everyone. I think when I did that tweet, I said, what do you guys think about colloidal silver? I'm getting a lot of requests. I think we got close to about 1,000 retweets or 2,000 retweets, and it went viral all over the world. So it took me a while to put all this together. Before I start, as many of you know, I am a working scientist and an inventor. I run a couple of different companies. And one company, CytoSolve, which I talked about. I also run an institute, a university called Systems Health, where my goal is to retrain all of you, or really expand your training into taking a systems approach to anything, be it your body, be it your computer, be it society, transportation systems, everything. And the reason for that is I believe we need to go beyond left and right. The left-right paradigm doesn't really lend itself to finding truth. It basically goes pro-vax, anti-vax, pro-GMO, anti-GMO, pro-climate, anti-climate, pro-guns, anti-guns. And in that pro-anti environment, we never get to the truth. A systems approach allows us to always find the truth because we apply the scientific method. A systems approach is based on understanding the interconnection. So some of you may know, as a systems guy, as a systems scientist, I took a position against the Paris Accords, not because it's pro-climate or anti-climate, but because the Paris Accords increases pollution. And I believe all of us want to lower pollution. And when you look at the Paris Accords, it basically incentivizes China to double their pollution from 11 billion carbon tons to 22 billion. And that basically gets to a point where China has to buy carbon credits, and that'll boost up the carbon credit market, and a few people are going to become trillionaires. So when I came out against that, people call me a right-winger. Similarly, or alternatively, when I took a position against genetically engineered foods based on a molecular systems approach, when I showed that genetically engineered foods don't have any safety assessment standards, people call me a left-winger. But the reality is, it's a very, very divisive way of looking at the world, and we never get a truth. So every one of you knows that I'm running for United States Senate, and if you're in the United States, you can go to Shiva for Senate and support the campaign. If you're out of the United States, you can also go there and read about the campaign. But anyone in the United States, we need your support, because our campaign for U.S. Senate is not just some campaign, some guy just running for political office. I'm running for political office because it's about delivering significant change to all of you. And what that means is that we need to take a systems approach to understanding how the world operates. And that's fundamentally what the campaign is about. So if people go to shivaforsenate.com, let me bring it up, you'll get a sort of a real holistic understanding of what this campaign's about. And the campaign is really about taking a systems approach to even campaigning, okay? So what we're saying here is, if you go to the website, you'll see that you can pledge to support the campaign. But more importantly, what you can do is, if you go to the main page, is that you can support the campaign by supporting yourself. As I mentioned, the purpose of our campaign is truth, freedom, and health. We need to support freedom, open debate. We need to fight censorship with the Digital Rights Act I've come up with. That will enable us to practice science, real science, to get to the truth. And from truth, we can identify real problems and real solutions to get to health. And with strong bodies, strong infrastructure, we can fight for freedom. Now, those of you in the United States can click on the donate button, and you can support yourself and the campaign. It's a reciprocal relationship where by donating to the campaign, ideally you can donate 25. If you can't, you can do whatever you can. But the goal is, System and Revolution is a book that helps you understand molecular systems, control systems, your body is a system. It gives you the core principles. It's about 108 page book. I recommend you read it, get it. It's an ebook. It's nothing. It's about 40 years worth of knowledge consolidated. But using this book, then you get the laboratory, call Your Body, Your System, where you can practice those principles to understand your body as a system. Now, I don't want to leave anyone outside of the United States. This is for people in the US who can legally support a campaign. Many of you have said, hey, I want also Your Body, Your System. Well, those of you can go right to yourbodyyoursystem.com, and you can click Get Started Now. It's the same thing. You get the same features, everything, the book, the tool. And so you can get it for anyone outside of the United States. But the tool really takes these systems principles, the principles of transport of energy, conversion of energy, storage, helps you identify yourself as a system and where you are. Then you can apply these systems principles to understand how your body as a system is disturbed, let's say by stress and work. That's the black dot. And then you can identify how to bring your body back to itself through input, through exercise, medicine, such as food, supplements, etc. So this is really a way for you to understand how your body is a system. The other thing I wanted to share with you before I start is that when you take a systems approach to the body, which we'll go over, you'll start understanding that your body has what I call an important operating system, which is called the immune system. And you can go to truthfreedomhealth.com. You can look at all the different videos I've talked about, but fundamentally, the body, the core foundation of the body is the immune system. If you support that immune system, your body will take care of itself. It supports itself. But if your immune system is weak, dysfunctional, pre-existing conditions, your immune system, when a virus or pathogen comes, will attack itself. That's the important thing we need to understand. It is a dysfunctional and weakened immune system that attacks inbound viruses and pathogens. It's not those things go attack you. They are merely coming in to use your body system to replicate itself. But in the normal cases, we'll walk through your body. if it has the right nutrients, vitamin D, vitamin A, vitamin C, the zinc, the iodine, a whole bunch of other, you properly nourish yourself, your body will support itself. For example, in Boston, the average age of someone who died from the coronavirus was 82 years old. Okay, the average lifespan is 80 years old. As you age, your immune system weakens, so you need special support, right? So what we are doing is, as you know, the businesses have been shut down. Nearly 38 million people have lost jobs. A lot of the restaurants, small business owners, the real economy was destroyed while the fake economy prospered. And so I am in Boston. Those of you who live in Massachusetts, those of you know have been know of Boston. It's where the American Revolution took place. And interesting enough, there are some very powerful historic sites. So this Saturday, which is tomorrow, I've posted up on our site, we're inviting people to do a walk with us. It's really a walk for truth, freedom, and health, where people can, let me take you over here. If you go to the site, again, the main site, you can scroll down and you'll see we have various events taking place. But one of the events we have taking place, it's called Dr. Shiva's Walk for Truth, Freedom, and Health. And I encourage everyone to come here, but it's really about supporting your community, build your immunity. So at 10 a.m., we're going to meet at one of the monuments called Bunker Hill, the Bunker Hill Monument at 10 a.m. tomorrow, Saturday, June 6th. And then we're going to walk over to check out the USS Constitution, then walk over to the Old North Church, and then walk over to the Paul Revere House. This is about a 45-minute, leisurely walk. And then we're going to end up at the North End. So that's 10 a.m., 10:30, 11:30, we'll end up there. And then we're encouraging people to support the local businesses. When we arrive at Paul Revere's house, we've listed some restaurants which are having takeout. And the North End is the Italian part of Massachusetts, where we're encouraging people to come and support and order food, takeout, and then take out to the streets. No one can stop us from eating out on the streets. So that's what we want people to do. I wanted to let everyone know that this is a way we gather as friendships. We boost our immunity, right? We know that social interactions, friendships, boost your antimicrobial compounds in your body and bring down your inflammatory compounds. So that's happening this weekend. Any one of you out there, wherever you are, tell your friends in Massachusetts. And then in North End, we're going to give people lawn signs, bumper stickers for the campaign. So there you go. So let me now start today's lecture about colloidal silver and its antimicrobial effects. And let me just start the PowerPoint here. 1 second. And I put together some slides today that will hopefully help walk you through it. And one of the things I try to do is to make the discussion accessible to all people. So I try to take it in a methodical way that no one feels left out. So I hope everyone can follow along. And if you can't, put questions up, and we towards the end we'll try to answer all the questions that everyone has. Okay, so don't feel like you're left out in any way. And we're here to support your knowledge, learning, and that's really what my job is, to really educate people on a systems approach to doing this. So let me start up here. So let me share the screen and share screen and go here. Let's start here. Okay, so here we go. There we are. Okay. So I hope everyone can see this. So what I want to start with today is really talking about colloidal silver and antimicrobial effects, a molecular systems analysis. So again, as I mentioned, if everyone goes to vashiva.com, you know that I do many different activities. I'm running for Senate, as I mentioned. I created the first email system. But one of the other systems I created that came out of my MIT PhD work is a technology called CytoSolve. And CytoSolve really allows something quite profound. We have created a technology that allows us to use the computer to model molecular pathways, diseases on the computer, so we can eliminate the need for animal testing and figure out how different combinations of compounds, natural, food, medicines actually affect. We've discovered some amazing combinations. We help a lot of amazing natural products companies figure it out. This technology was used to show how GMOs have no safety standards. So it's really a breakthrough technology for modeling biological functions, immune system, on the computer that I call in silico, so we can discover medicines faster, cheaper, and safer while eliminating the need for animal testing. As many of you know, this is a current model how pharmaceutical companies develop drugs. They discover a compound, they test in a test tube, kill a bunch of animals, and they test on humans. This takes a long time. It takes 13 years, very expensive, and it's not working. In fact, year over year, as the bar chart shows, the more and more money they spend on R&D process like this, they're actually discovering less and less new drugs because the FDA is actually not even allowing many of these toxic drugs. That's how bad they are. In fact, here's another graph. The orange line, more spending, less and less new molecules are being approved. So when I came back to MIT in 2003, one of the very, very exciting things that was taking place was systems biology. And systems biology was saying, if you want to understand complex functions, like, hey, does colloidal silver really affect this? A lot of controversy. If you want to understand what's going on with cancer, it turns out that we need to take a systems approach. And the reason this concept came out to be was because in 2003, what we discovered was that the body, compared to a small worm, we knew a worm had around 20,000 genes. So in 1993, we thought, wow, when we started the Human Genome Project, the human being must have about 1 million genes or 100,000 genes. And as you can see from this graph, when the Genome Project ended, it turns out we only have a very few number of genes, okay? We only have, in fact, 20,000 genes, the same as a worm. So this gave rise to a field called systems biology, which said, look, it's not the number of genes, but it's all the molecular reactions that take place. We have to go beyond the human genome and start looking at the molecular reactions, which means the molecular pathways. And that led to a field called systems biology, saying if you want to understand the whole, you got to connect the genes, the proteins. It's a much more of a holistic solution. And part of that was, if you think about the cell as a very complex system of a lot of chemical reactions, one of the challenges was, could you mathematically model the whole human cell? Because if we could do this, we could really model diseases and we could eliminate the need for animal testing. So that became my PhD work starting in 2003, ending in 2007. And by the way, these chemical reactions. This is one little chemical reaction. These were starting to become models. But if you wanted to model this complexity, was too difficult, or something like this. So I created this technology called CytoSolve, which helps us decentralize a problem where we look at a complex problem not as just any one big problem, but we break it up into different pathways. We model those individually, and my technology has some very powerful mathematics that allow us to integrate those so we can model very complex functions. I wrote a very important paper on it, but more importantly, what my theory was, this very old process can be converted to this process where we mine the papers, we model things on the computer, and we can understand how compounds work long before we do cell testing. Very much like how we work with an airplane, right? We don't throw a pilot in test flights. We don't throw them in the in vitro test, or wind tunnel testing. We do everything on the computer. We work out all the problems first. So that's what CytoSolve is. And so we've created a very powerful way of decentralizing. And one of the things I'll be talking about is, given all the feedback, we're going to make CytoSolve open to a lot of people so we could do joint research with citizens, what we call citizen science. So that's going to be coming out soon. So keep an eye out for that. So let me go back to this. So one of the important goals here is that using this approach, we can literally start understanding complex things like the question of colloidal silver. And what we do is we can take papers in a field. We can mine those papers, extract out the molecular mechanisms, build a systems understanding, and then mathematically understand it. So let's begin with understanding how a virus works. So that's the background on the tool set, as I promised you. But one of the things I want you to understand is that when a virus comes to you, it goes through really 4 processes to try to infiltrate your system. And a virus, what it's trying to do is to hijack your household, which is your cell, and enter it, step 1, then use your Xerox machine, which is your ribosome mechanisms for replicating itself, hijack, that's like a thief trying to come into your house, hijack your maybe you have a special Xerox machine which lets the thief copy himself and then replicate himself, repackage himself, and transit, okay? So the virus process that we'll talk about, virus replication, really has 4 steps, okay? One of them is, and we'll walk through it. First, the virus comes in. I'll walk through it in a couple ways. The virus, first of all, comes into your cell right here, as we're seeing, okay? And what it attempts to do is then enter the cell. So first is entry. Then it releases its nucleic acids, which is its blueprint to replicate itself. And it takes advantage of your Xerox machine, your ribosomes, and replicates the RNA. That's step 2. Then it reassembles itself, step 3, and it exits. So let's walk through this a little bit closely. So for example, in the case of the coronavirus, it enters by attaching to this ACE2 receptor. So there's a coronavirus. The spike proteins connects, and it tries to get into your cell, but it has to use a process called glycosylation, okay? This is how it tries to get in. By the way, as I talk about hydroxychloroquine actually stops this process, just as an example. Next, what happens is after it gets in, the next thing it does, it attempts to, that's step 1, it attempts to replicate itself by releasing its blueprint, what's known as the ribonucleic acid, into your ribosomes, and this is its replication process, right? So it starts, that's what the green is. It starts replicating itself. That's step 2. Then, after it replicates itself, it then attempts to repackage itself right here. It starts reassembling itself. This is step 3, as you see, back into its components. And then the last step is it exports itself out. It releases. So those are the 4 steps, okay? So let's talk about silver. I don't know how many of you have tried colloidal silver. I haven't actually used it, but I know in traditional systems of medicine, like Indian medicine, very small dosages were used as antimicrobials. And in fact, the modern research shows the same. So now let's talk about the forms of silver, okay? I hope everyone's cool. Let me just take a quick check if there's any questions out there. Okay, oh, someone says I use it every day. I agree, Shiva for president. Great, I'm trying it daily, great. So what I wanna arm you with right now is to understand the different forms of silver, because when I started this discussion, a number of you wrote to me with your experience with it in the different forms. So we wanna make sure we're covering that, okay? So when you look at silver, you know, it's a chemical on the periodic chart. If you remember chemistry, it's chemical number 47 on the periodic chart. This is the molecular weight of it, 107.868, and its symbol is Ag, okay? Ag is a symbol for silver from a chemistry standpoint. One of the things, it's most extensively studied metal for centuries, one of the most extensively settled for centuries, and it's known for fighting infections, preventing food spoilage, and wound healing. It's non-toxic to humans at very small concentrations, so listen carefully. I think there's a video you'll find out about some guy who became blue, you know, I think 60 Minutes, bunch of, and he was, it affected him in a you know, look, all of these medicines, food is medicine, can affect people in different ways. In one size does not fit all. So you wanna, I think it's a very interesting story. But fundamentally, silver attacks a broad range of targets in the microbes. So microbes we'll talk about could be fungi, viruses, bacteria, parasites, and can be used in combinations with antiviral drugs to improve efficacy. In fact, recent research came where they combined silver with an antibiotic, less use of the antibiotic, it had better effect. But this is what silver is. Now, silver comes in various forms. Here are the 3 major ones: ionic silver, silver nanoparticles, and what we call ionic colloidal silver, okay? These are the functionally like 3 different forms that silver comes in. So ionic silver looks like this. So it's really a silver salt. It's, you know, silver nitrate, okay? And what happens is it's an ion of silver bonded to this salt, okay? So this is, but when you put it in water, it separates into the ion, which is ionic silver, and the nitrate anion. So this is positive, anion means negative. Now, you simply can take silver salts and you put it in aqueous medium, which means water. And what's important to note is that the size of the silver ions, which is this right here, is about 0.1 nanometers, okay? Nanometers, very, very small particle size, 0.1 nanometers, which is 10 to the minus ninth meters, okay, which is a millionth or a billionth of a meter, okay, a billionth of a meter. And it's historically used as an antimicrobial agent. And the smaller the particle, better, and what you find out is the ionic silver is better than silver nanoparticles, which is we're going to talk about. But it's relatively less stable, okay? So that's the negative side of it. But the ionic silver has a lot of potent effects because how small it is, because it can get into those cells we'll talk about, but it's also less stable. Let's talk about silver nanoparticles. So silver nanoparticles are a bunch of particles, that's just blue, that clump together, okay? And notice they're about less than 100 nanometers. So 100 nanometers is about 1,000 times the size of silver ions, right? So because you can have small clumps, you can have large clumps, but it's basically surrounded by material, but inside of it is these silver nano, this is what's called a nanoparticle, this whole thing. Inside of it are a bunch of silver ions in there, okay? Or silver embedded in there. And these particles, the smaller the particle, which means the smaller the nanoparticle, higher microbial activity, but they tend to self-aggregate and form clumps of nanoparticles, which reduce their antimicrobial activity. So again, these silver ions, smaller size, more antimicrobial, the nanoparticles, larger, they can form clumps. Okay, the third one is ionic colloidal silver. What looks like this, a colloid is really a suspension of a solid in a liquid. So here you see these you notice they're varying sizes of these particles, and they're not just nanoparticles, they're both nanoparticles and ions. Typically, colloidal silver is the black is like a liquid, and these are suspended in there. And typically, the composition is around 80 to 95% of an ion, silver ion, and about the other 5 to 20% is a nanoparticle. So it's literally a combination of this and this, okay? That's what it makes up. And these tend to be, because you have the ions too, around 20 to 45 nanometers, they provide a stable form for releasing silver ions and having sustained antimicrobial activity, and there's no risk of aggregation. So while the silver ions are they're very effective but highly unstable, these are very, very stable but too big. These have the middle path property, and they sort of, if you look at any one of the particles, you'll see the nanoparticle surrounded by the ions. Okay, so this is really a colloid. It has the benefits of both. Okay, let me just check if anyone's got any questions about this. I hope that's clear. So those are the three types. So someone said I use sovereign silver 10 parts per million, 2 ingredients, 99.99%, pure silver, and pharmaceutical grade purified water. Okay, cool. So now let's go back and let's talk about how this, what is known in the literature. What is known, again, in the literature, and we went and aggregated all the literature, what you find is that silver, interestingly enough, does have antimicrobial effects, okay? And a number of, and this is not something that people should be censoring. It's not something that people should be attacking. This is from the scientific work across many, many papers. It's shown to be highly effective against various microorganisms, bacteria, salmonella, streptococcus. You can look at the various other forms, C. difficile, B. vulgatus, S. Tiferium, and S. sonal. I'm sure there are others, but bacteria are one type of microorganisms. But it has also been shown to be effective, again, at the right dosage, low dosage, against retrovirus and cephalomyocarditis virus, vaccinia virus, HIV-1, coronavirus, TGEB, HIV-1, HSV-1, RSV, influenza, monkeypox, and hepatitis B. Okay, so silver has been shown to be there, and it's also been shown to be effective against certain types of fungi, Candida, Cryptococcus neoformans. So this is from the literature. So that's important to understand, that there's a body of literature which shows that it has antimicrobial effects. Okay. What I now want to do is to talk about how this can occur, because I want to arm you with some knowledge from a molecular systems approach on how it works. And we're going to take two examples. We're going to look at viruses, and then we're going to look at bacteria. And silver works in differentially in different ways against how it operates in trying to stop viruses versus bacteria. So let's go back to the chalkboard here and look at that. So when it comes to viruses, it has, by the way, MO means mechanisms of action of colloidal silver, the nanoparticle, okay? So if you look here, I'll go through this first of all. Here is, we're looking at a cell, okay? And if you remember, the virus comes in on the left side into the cell, it takes over the cellular machinery, and it replicates itself like I walked through. And what colloidal silver does, it inhibits, it does two things. It inhibits the entry of the virus. Remember, we have this four-part process: enter, replicate, reassemble, and transport. So the research shows the mechanism of action is, and I'll get into the details, one thing is a colloidal silver stops the entry of the virus into the cell, okay? And then it also inhibits viral replication by attaching to the virus genome and essentially stopping it from replicating. So it has two effects at the two levels here, and also the viral replication and preventing the genome replication, okay? So let's look into a little bit closer. So if you look at this diagram, here's a colloidal silver, here are the viral particles. What it does is it interacts with the surface glycoproteins, okay? And what it does is, because it interacts with the surface of the glycoproteins, it inhibits the silver from attaching and performing the activity of unlocking the receptor to get in. I hope that's clear. So it literally attaches to the surface proteins and stops that reaction. If you don't remember, let me just go back here. It stops this reaction right here, if you remember, okay? This part from it entering the cell right here, okay? So it inhibits that because it literally starts sort of blocking the glycoproteins on the surface of the virus right there, okay? So that's one thing that silver, colloidal silver does from the mechanistic understanding. So let me go back here. So that's something important to appreciate, which is very cool. The second thing it does is, once, if in addition to this, the silver particle literally attaches to the viral genome, okay, and attaches to the factors and proteins. So remember, this stops the replication process. There's Xerox machine from replicating, because it's basically polluted the ribonucleic acids, or if it's a double-stranded RNA inside that the virus releases. So two ways that it affects from the viral end. Now, let's go to the second case, which is antibacterial. Now, in the antibacterial case, silver colloid binds, it does many things, multiple things. It really screws over a bacteria big time. It binds to the cell membrane, which is the outside here, and leads to the rupture of the cell wall within minutes of contact, within minutes, okay? The other thing is, once it gets inside the cell, the colloidal silver interacts with the ribosomes, which is the Xerox machine, and it leads to deactivating of the protein synthesis, so the virus can't replicate. It also directly interacts with the DNA of the bacteria, and it leads to denaturing and disruption of the cell cycle. It also interacts with the sugar metabolism of the bacteria. So basically, completely hot, silver basically destroys the bacteria's sugar metabolism in the mitochondria and the energy metabolism. And then it causes stress. It basically causes oxidative stress, which leads to DNA damage of the bacteria. And it disrupts the internal molecular signaling. So let me go over that again. So here's the bacteria, which is something you don't like. The silver gets in, and first of all, it destroys the cell wall within minutes. Then it gets in, it also destroys the mitochondria of the bacteria, which is the energy production center. It also goes right into the nucleus of the bacteria and screws up the DNA. It also screws up the ribosomes, which are replicating, the replication process of protein synthesis. So it affects, definitely affects antiviral actions through two modes, virus entry and virus replication. And when it comes to bacteria, it affects multiple modes, all right? So in summary, what we have is that silver has a broad antimicrobial effect against bacteria, broad, fungi, and viruses. Now, antimicrobial activity, we have to remember dosage is critical. And this is something that I think, as research is going, this is something we need to focus on. How much is what's important? Too much can be toxic, but these are low dosages. So the idea is low dosages. And in summary, the microorganisms, viruses or bacteria, are unlikely to develop resistance against silver as compared to antibiotics because silver acts on a broad range. Remember, what we talked about, remdesivir, or the new vaccines that they're developing. If the virus mutates, it doesn't, you can't do much. But silver, from the mechanistic research that we just completed, seems to have some broad effects. Okay, so it can stop. It's hard for the bacterium to deliver, even though it's mutating, or the virus to really have a resistant to it. So again, it ruptures the microbial cell wall in the case of bacteria. It prevents entry to the host cell in the case of virus and bacteria. It inhibits the microbial growth by shutting down the genomic replication in both virus and bacteria. And it breaks down the cellular machinery of energy production, the mitochondria. That's in bacteria. It's not known whether it does that. Well, it doesn't do that in the viruses because they don't have bacteria mitochondria. And then it does the induction of cellular toxicity via oxidative stress. And that's through bacteria. And it breaks down the cellular communication. That's virus and bacteria. And what they're finding is that silver can be used with other antiviral, antibacterial drugs or components, etc. So this is sort of the summary chart. So when you look at it, stops viral entry, it stops viral replication, and it looks like it also will affect the viral membrane disruption from the work that's been done on bacteria, okay? And this is still ongoing, but it affects 3 parts of 4 of the processes. So it's quite incredible. Silver, in conclusion, I had not studied it before, but I was quite impressed by it. Silver really appears to have a broad effect on that 4 parts of the viral replication process in bacteria and viruses. So there you go. And I think it's really unfortunate that the scientific establishment doesn't really want to look at this. But the good news is there are good scientists who have looked at this. The overall establishment is probably afraid that this may compete with their traditional vaccines or pharmaceutical drugs. So let's look at, so we can take some questions. Colloidal silver is awesome. There's someone writing about that. Thank you for educating USA. People how it works, you're welcome. Yeah, people need to understand that I do this because I really, really love taking a systems approach. And that's why I want to encourage all of you to take a systems approach. One of the things people keep telling me that I do not do and people want me to do is to let people know, separate from this research work I do, I also have a university or a school that I've created, an online school. One entry to that, as I talked about, is people start learning how the body is a system. You can go to Shiva for Senate. You can get the book and the tool. But then I have an advanced course program, and I keep forgetting to tell this because it's a whole nother part of my life that I do. But people have said, Dr. Shiva, can you please let people know that the fact that you also do stuff, you have a university that you run, a school. So we call it Systems Health. And Systems Health is a way that you can actually, beyond the initial investment that you guys can do to understand Systems Health, and System and Revolution. This is an actual online school that I created after my research work, after finishing MIT and integrating Eastern and Western medicine. But there's a foundations course. You can understand fundamentals of systems theory, systems biology. You can understand Eastern systems of medicine. There's a whole course, and you can learn how to interconnect it. There's an online laboratory that you can use. There's a number of books that are included. You can also, those of you who are more dedicated, you can get Systems Health certified. You can take the courses, but in addition to that, you can use the portal to help others. And then you can also take a whole range of other courses. There's a course in systems medicine where you can really start understanding how different kinds of herbs work at the molecular, turmeric and ginger and snake root and ginseng. So we've done a lot of work, but this is people should explore it, understand it. But a number of people have said, hey, you haven't been sharing enough with us, but you only have so many hours in a day. But I want to let you know that's also there. But what I've shown you now is if you go down to the molecular systems level, you can really start appreciating how this works. And again, this is brought to you by the technology I created for my MIT work called Cytosol. Let me take some questions. Jen, if you're there. Jen, are you there? Let me see if Jen's there. I don't think it's pure enough for what I'm seeing in the comments. Let's see. Whole Foods in Closter won't carry it. Yeah, it's interesting. I've heard that a number of the people are not carrying it. How does it affect Candida? Desperate. So remember, Candida is a fungus, and we can do a separate talk on that. We can go to the literature and try to understand that, but Candida is really a fungus. So what silver appears to do, if you look in the first two cases, is first of all, affect the cell walls, and it looks like it takes over the virus machinery and it destroys the replication. So it is doing something, I would presume, in that area. How does it help heavy metal detox? I am not sure. We can look into that. It's a great question, but it's a good question. I can look into that. Look, one of the ways I'm going to take a guess at it, remember, silver is a positively charged ion. And when you have ions in colloidal things, they can bind to other things and take them out of your body. So my suspicion is that the ionic attributes of colloidal silver help it bind to certain metals so you can take it out. What if you already have a high level of aluminum in your body that stops immune system? Well, it's very interesting. Look, let me just say one thing about these metals. In traditional systems of Indian medicine, in a system of medicine called Siddha, you can look it up, Siddha. We can talk about cancer, Kathleen. So what you find is that in the system of Siddha, one of the branches of Siddha was using heavy metals like silver, but small dosages. It turns out if you use a small dosage of arsenic at low levels, it actually supports heart function. It's been known for years. In fact, the heartworm pills that they give dogs have arsenic in them, okay? If you look at small dosages of mercury, it actually helps neurological function. Too much hurts it. And so I think one of the things we need to consider is it appears these metals at low dosages have positive effects, and at higher dosages they hurt. Nandan, this is a very important point. Indians in India have been using silver pots for cooking besides brass pots for centuries. Maybe they knew something. In fact, in India, you would cook or store water, for example, in copper, antimicrobial. You serve food in silver plates. So clearly the ancients knew about the value of substances like silver and copper, but it's at the right dosages, okay? Too much, like anything, can have effects. Now, when it comes to cancer, someone just asked a question. There's a growing concept as we study the immune system that viruses, bacteria, overload, for example, lots of sugar. If you eat lots of sugar, it leads to candida. Your body creates gliotoxins. It suppresses the immune system. And when you suppress the immune system, you create all sorts of problems that lead to things like cancer. So one of the important things to understand is that when you go to cancer, which is a disease, and you sort of go down many layers, you find out ultimately all of this comes down to inflammation, which is a disruption in the immune system. So obviously that disruption is caused when you have a weakened immune system or overload of some of these things. And I believe what we just shared with bacteria and viruses, silver can be beneficial, again, at the right dosage. What about silver fillings? Good question. I'm familiar with some of the effects of mercury amalgams, but again, if you look at what we just shared, the silver fillings, depending on what they're bonded to, okay? Now, if they're in some stable form, you could argue that if your body's getting some low dosage, that it may be beneficial. Again, it's what it's bonded to, what's called an amalgam. What is that silver bonded to, and what is the rate of release of that into your body? Now, if it's bonded to something that you're getting tons of silver being released, there could be potential toxicity. Maybe the bonding is so stable that minimal dosage is going out, and maybe it could be potentially valuable. I'm not sure. I think it's an area of research. Great question. Business Wire, Aginon Tech announced ionic silver is found to effectively deactivate human coronavirus, June 13th, 2005. That's interesting, right? Look, I think, I just shared with you that, tomorrow morning, we're going to be going to the Bunker Hill Monument. We're going to walk over to the U.S. Constitution. Then we're going to go over to the North Church, and then we're going to end up at Paul Revere. But one of the reasons that we're doing this is we want to follow that freedom trail. But a lot of the businesses in Massachusetts throughout the world have been shut down under the presumption that the virus comes and destroys you. It's not true. A solid, boosted immune system. We need to support our community and boost our immunity. So what we're going to do in the North End is when we arrive, we're going to order takeout food as a community to support the restaurant community. We're going to hang out in the streets. They can't stop us. And we're going to eat food outside. But one of the most important things is that we need to focus on boosting the immune system. When you have friendships and you're not socially isolated, you know what happened? Your body produces antimicrobial compounds, bottoms up. It does it for you, okay? Silver has a lot of antimicrobial activities, right? So as someone just shared from India, so probably very low dosages that you're getting, if food is medicine, maybe eating on those silver plates supports you. So it goes into that 2005 report someone just shared. Let's see. Thank you for all the information. Thank you very much. Thank you for supporting the campaign. Jane Garber Locklear writes, yeah, so everyone remember, if you're in the United States, you can support our campaign. And when you support us, I give you information so you can become leaders. And that's one of the main goals here, to educate you on a systems approach. Also, I encourage everyone to write to me personally at vashiva@vashiva.com. If you have other kinds of things that we want to do, some people have said we should look at, for example, different types of herbs, Artemisia that we should look at. But if you have other ideas, we can do that. And also, to you entrepreneurs out there, we're going to start creating a program where if you have ideas and you want to say, hey, look, I think this combination could be useful for this, we can run that through Cytosolve, and we're going to start creating an innovation program to help the world so we can take people with ideas, support them with this technology to create and identify new things that work. But thank you, Jane, for your support. Silver does not kill good bacteria like antibiotics. Yeah, so Joanne Snyder writes that. And that's a very interesting thing. One of the things that I want to do as a follow-up to understand how silver affects bad bacteria versus good bacteria. And that would be an interesting thing to understand. And that's one of the things we want to do as a follow-up research. Someone says, please speak on vitamin poison. Also, I recently had shingles and was told it was a rebound of chickenpox, and they wanted to give an additional vaccine, and what would rebound? I think I understand. So vitamin poison. Amos, can you refine your question a little bit? I think I understand what you're talking about. Look, one of the things that we need to understand with the reoccurrence of this is that when you get chickenpox a natural way, very low occurrence of it coming back. But it turns out when you get the vaccine, that there's a higher occurrence because the vaccine is not as efficacious. Obviously, it has all these deleterious effects based on your body type to going through the natural immunity. So that's why some people are getting this reoccurrence. Someone said, thank you. I'm drinking my turmeric, lemon, and lemon tea with honey right now. That's great. One of the things is, if you get up in the morning, lemon, a little bit of lemon in warm water is an amazing way to support your overall metabolic function and support your liver. So it's something you may want to try, but I think I may make a cup for myself after this evening. Let's see what someone says. I accidentally clicked on that. Thank you for your advice, of course. So if there's no other questions, I hope this was valuable. And I hope those of you outside of the United States, tell your friends in the United States, if they know people in Massachusetts, to support our campaign, because our campaign, I'm running for US Senate, and it's really a campaign for truth, freedom, and health. Rarely do people like us, people who work for a living, inventors, scientists, people with skills, enter politics. So it's a big commitment of my time. Many of you know I love doing my science. I love creating. So support the campaign. Tell people to come out and vote for us. Our election is September 1st, is our primary election, and we must win that. We win that, we're going to win the whole thing. In Massachusetts, there's two parties. I'm running as a Republican, but I'm beyond left or right. So that's what I want to leave people with. They force us into running one of these parties, but we have to move beyond left and right. We have to take a systems approach to solving problems. And a systems approach lets us look beyond all the censorship, look beyond all the nonsense, and come to truth. So I hope this was valuable for people today. So you're armed with a molecular scientific understanding of recognizing that silver does have very powerful antibacterial effects. Dosage is important, and it does affect 3 of the very main of the 4 subsystems in viral replication. And obviously more research needs to be done. People need to study more, and I'll try to keep you posted. Again, write to me, vashiva@vashiva.com. Share with me any other ideas you want for videos, and I'll do that. Someone said, vote for him. We need support. Those who are honest and good. Thank you, Soulmate Healing. Anyway, be well, be the light. And again, tell your friends that tomorrow, 10 a.m., we're meeting at Bunker Hill Monument, 10:30. We do the walk. Should be, as I understand, it's not going to rain tomorrow. And then we're going to order food, takeout in the North End. Great Italian food, great neighborhood to help the local restaurateurs. Thank you, everyone. Be well. Thank you.